happy Thursday. We are going to review everything that you've done in Chapter 12 to try to help you be better prepared for the quiz that you have in over all of Chapter 12 next Tuesday. So I'm essentially just going to walk you through in these notes one example of each type that you saw throughout the course of this chapter, and then you will have a short assignment to complete for me practicing these skills to make sure that you are ready for that quiz. So when you see a single fraction that's asking you to simplify, what that's asking you to do is to make sure that the numerator and denominator are in their most factored form, and then look for anything that's the same on top and bottom that could cancel out. So if you notice, the numerator, or the top here, is involving a p squared, which means that if there's not a common factor that we can take out of all three terms, which there's not, then we are going to need to factor it. So this is where I've been using box method in these notes. So for box method, remember there would technically be a 1 here. So we always multiply the first number times the last number, meaning that we're looking for two numbers that multiply to be 10, and those same two numbers have to add to be that middle value. So they need to add to be -7. So what would those two numbers be? Hopefully you came up with -5 and -2. -5 times -2 is +10. -5 plus -2 would be -7. So we can go ahead and create our box. In the upper left-hand corner, we would have p squared. And in the bottom right, we would have 10. And then in the other two squares, we would have -5p and -2p. Remember, order does not matter there. So now we're going to look at each row and each column. So p squared and -2p, they have a common p. -5p and 10, they have a common 5. And then remember, because this, where the arrow leaves, is negative, that means that that common factor becomes negative. Going horizontally, p squared and -5p, they have a common p, which then leaves us here with -2p and 10. Their greatest common factor is 2, and again, for the same reason, because where the arrow leaves is negative, this becomes a -2. So this means we can go back to the original problem and we can rewrite the numerator as p minus 5 times p minus 2. So p minus 5, p minus 2. In the denominator, we have p minus 2. That's not quadratic, so really all I'm checking for there is a common factor other than 1, and p and 2 don't have one. So we're going to leave that denominator as p minus 2. So we are now looking for anything that will cancel from the top and bottom. And what we have that would cancel would be p minus 2. So this will cancel with this, which means that our solution is p minus 5, just what we have after we've simplified. On this problem, notice that this is a division problem. And when you learned about division, remember that your first step was to do keep it, change it, flip it. So we are going to start by keeping the first fraction the same, changing your operation to multiply, and flipping over the second fraction. Now we're going to look at each numerator and each denominator to see if there's anything that we can factor out, if we need to do the box method to factor, any ways we can break down. So 3n plus 12, do those two have a common factor? They do, and it's 3. 3n divided by 3 would leave us with n, and 12 divided by 3 would leave us with a +4. In that first denominator, I just have a 3. Because that's a monomial, a single term, I'm going to leave that alone. Moving over here to the second fraction, I have n plus 9. N and 9 do not have a common factor other than 1, so I'm going to leave that as is. And then in that denominator, I have n plus 4, Again, n and 4 do not have a common factor other than 1, so I'm going to leave that as is. Now, with multiplication, remember that you can cancel both vertically and diagonally. So those are the two directions that you can cancel when you are dealing with multiplication. So as we look here, vertically, I can take those 3's out, reduce those 3's away, and diagonally, I can reduce out this n plus 4, which means that in the numerator, all that I have left is n plus 9. And in the denominator, it looks like I have canceled everything out. Technically, there would still be a 1 there, but really to have this in simplest form, we would not need to write that 1. So we could write our answer as just n plus 9. On this problem, you are looking at a multiplication problem. So when we have multiplication, we do not need to do keep, change, flip. Now, in this case, what's interesting is that it does not appear that you have two fractions. And this is not the first time that you've seen that. So the first part, the part that comes before the multiplication sign, does not appear to be a fraction. But remember, technically it is. It just has a denominator of 1. So for a lot of you, I think it would just help for you to write that in. Even though it doesn't actually change anything about the problem, I think it will help you to see that. So now we're going to approach this just like we did the last problem. We're going to simplify, factor, break down every numerator and denominator and look for things that we might be able to cancel out. So our first numerator is x plus 10. It's not quadratic, so I don't need to do box method. Do x and 10 share a common factor other than 1? They do not, so that's just going to stay x plus 10. And that first denominator is just going to stay a 1. Again, if it's a monomial, meaning a single term, you're not going to be able to break it down. So times, jumping over to the second numerator, I have 3x plus 1. Do those two share a common factor other than 1? They do not, so we're going to leave that as 3x plus 1. And then I get to this second denominator. So this second denominator is quadratic. It has that x squared, meaning that I'm likely going to have to do the box method. Before I start the box method, I should always check for a common factor that I can take out of all three terms, which in this case does not exist. So I am looking here for two numbers that multiply to be, so we are looking for two numbers that multiply to be -6, and those same two numbers need to add to be the middle number, so -5. So what are your two numbers that multiply to -6 and add to -5? -6 and +1. Now, if you were thinking -3 and -2, that does not work because a negative times a negative would give you a positive. So that's why that is not the correct factor pair. So now when we create our box, in the upper left, we are going to have 3x squared. In the bottom right, we have -2. And then we'll have -6x in one box and +1x in the other one. So in this first column, 3x squared and 1x, they have a common x. -6x and -2, they have a common 2, and because of this, this becomes a negative. Now moving horizontally, 3x squared and -6x, they have a common 3x. And then here, 1x and -2. Remember, when it looks like they have nothing in common, there's always a common 1. So we can now move back over to the original problem, and we can write that denominator as x minus 2 times 3x plus 1. Now, just like the last time, when this is multiplication, you can reduce or cancel vertically and diagonally. So what do you see? Hopefully you see these 3x plus 1s that will cancel out, but there's nothing else that will cancel here. So when we write our answer, in the numerator on top, The only thing there is x plus 10. And then in the denominator, we have 1 times x minus 2. Remember, when you multiply something by 1, it just stays the same. So that denominator is going to stay x minus 2. So this is your solution. All right, last question we're going to look at together today is this problem, which please notice is a subtraction question. So we have to pay attention to the operation symbols, or that quiz is going to be really hard for you in Algebra 1. You have to pay attention to that really first when you start the problem. So if you remember from the last lesson, which was just yesterday, what you learned is that really there's no need to leave it as subtraction. We can change it to addition, which makes it easier for us to think through, as long as we change the sign on everything in the numerator of the fraction that comes after the subtraction sign. So that means this would become a negative n and a negative 3. Now, to put these two together, they already have a common denominator, and remember, when you start to combine them, you combine the numerators, and that denominator stays the same. So that is going to stay 6n plus 36. So in the numerator, we have like terms, n and negative n. So n plus negative n, those would just cancel each other out. So we'll no longer have a variable in the numerator of this problem. And then we have negative 3 plus negative 3. Now, those do not cancel each other out, so be careful there. Negative 3 plus negative 3 would give you negative 6. Now, we are not done with this problem at this point because we need to check and see if this will simplify. In the numerator, you have just a monomial, a single term, so that is not going to simplify. But in the denominator, 6n and 36, they share a common factor. Their greatest common factor that they share is 6. So if we take out that greatest common factor, 6n divided by 6 would leave you with n, and 36 divided by 6 would leave you with 6. So now we can reduce this much like we did the first question. So these 6's will cancel each other out, which makes it look like in the numerator you just have a negative sign that's floating with nothing that it's attached to. Remember, if a whole area, either numerator or denominator, cancels out, there's still technically a 1 there. So in the numerator, we would have negative 1, and in the denominator, we would have n plus 6. This would be your answer in simplest form. So please go on in the module, make sure that you do the Canvas assignment I've posted for you. Just like all of the other times, you can do it up to 3 times. I'll take your highest score. Just make sure that you're good with this stuff before you take that quiz in Algebra 1 on Tuesday. Have a great weekend.